Hello, this is Mrs. Ellsworth. Well, so far we've learned how to take density of solids that have got a regular shape so we can use a ruler and find their volume. We've also found the density of irregular shaped solids, but now we're going to take the density of granular solids. If you look at all these different pictures, you'll see that there's lots of different granules or grains of things, from sesame seeds to jawbreakers to sand to some kind of seed there in the corner. Anyway, there's a lot of air inside of these different types of granules. Here is a close-up picture of sand. And look at the measurement there. It is showing that it looks like little rocks. And when you pile little rocks together, there's still a lot of air in there. And so we're going to be looking at how to find the density of sand, this nice white sugar sand. And we got to take into consideration all of this air. In fact, we'll have to use water displacement to displace all that air and figure out how much sand is in a sample. Anyways, we just can't pile a whole bunch of sand on a balance, to find the mass of it. If we put it in a weighing boat, then we could do that, but we're probably going to lose a little bit of sand granules in that transfer because it's another transfer of the materials. So to find the mass, just go and put your graduated cylinder, empty graduated cylinder on the balance and tare it. Okay, when you zero it out by pressing tare, it's right now not considering the volume of your graduated cylinder. So then quickly fill it up so far between 20 and 40 milliliters of sand. My sample here has got 50 in it, but I'd like you to take a little bit less than that. So then as soon as you fill it up, it doesn't have to be on a perfect number. Go and put it back on it and remass it. So in this case right here, since it already took out the mass of the graduated cylinder, the mass of this sample reads 89.1 grams. Okay, so since we've got this granular solid, it makes absolutely no sense to fill a graduated cylinder with water and start adding sand because the sand has so much air in it. Plus, the sand will stick to the sides, so if there's any water droplets along the sides, it'll just get stuck there. So again, your testing is ruined by those small little factors. Okay, here's a picture showing 40 milliliters of water and 40 milliliters of sand. Now imagine that you've got this in front of you. You will have to have a dry cylinder for your sand. Totally dry before you put it in there. Okay, and if you go and pour it into the other one, like I said, there's no guarantee that none of the sand will get hung up on the sides of it. So I recommend that you pour the measured water into the dry sand to find the displacement of the air in the sand. So this is how we'll do it. To find the volume, go ahead and take your graduated cylinder that you had with sand on top of the balance to find the mass. Okay, then find another one, preferably a wet one so that other people can use the dry ones, and fill it up so much with some water. I guarantee that you're going to be amazed at how much air is inside of the sand. But you can put in, 30 to 50 to 60 milliliters of water in the second graduated cylinder. Okay, so you have your lab sheet. On the third page, there's the granular solids density sheet, and it asks you specifically to find the mass of the dry sand. Okay, we did that on a few slides ago. Okay, now the volume of the dry sand. Okay, this is from an experiment done previously, so I just have these pictures up here showing it. Okay, and so I put in 50 milliliters of sand. I put in 30 milliliters of water. Okay, and then I have to add the water to the sand. See, add water to the sand and then report what volume of that one is. So I went and did that. Oh, what did I say here? Take notes off to the side of the measurements that we're discussing now in this video if it will help you or help your team be successful in this investigation. So don't go and write these values right in there like I am, because that's where you want to put your results when you do this lab. So go take some notes off to the side. I won't read what's in the margins. I'll just read what's on the lines for you. Okay, so moving on, we're going to calculate that volume of sand and water. Okay, and once we added the water to the sand, it read 63.1 milliliters. Okay, this is sand and water. This one here is just the water. So if we subtract these two, step 4 minus step 3, we'll find out how many milliliters of just the volume of the sand alone. So once you're done pouring your water into that one, quickly go hang up yours on the drying rack so the other class can have some dry glassware to work with. The one that is full of sand and water can be very difficult to clean. I will show you how to clean that in a really efficient way that a student showed me years ago, and it's kind of cool, and I will show you how to do that in class tomorrow when we first start. Okay, so we've done all of the measurements that we need to do now. So the rest of it's just all calculations. And I'm going to make some notations off to the sides to show you what numbers that we used. Okay, so we got to take step 4, the 63.1, and we've got to subtract step 3, the 30. So I will subtract those, and when I did that, I got 33.1 milliliters. Okay, and then for a bonus, I put in this question for you. Find the volume of the airspace of the dry sand in the volume of the dry sand. So to do that, we had to take this one up here, which was the sand and air, and subtract just the sand alone, just find how much the air was. So that was kind of cool. I thought that I'd show you that part and give you guys, I mean, that's not quite a third of the volume of the dry sand was actually air, but I remember being just surprised at how much air was inside sand, and maybe you are too. Okay, so let's look at the very last question. It has the mass of sand divided by the volume of sand. The mass divided by the volume. Okay, there's the mass up there. We put that on the balance a long time ago. Okay, and then we've got the volume of the sand. We calculated that one after we took out the air. Okay, and then you go and you divide the two. I took 89.1 divided by 33.1, and I got 2.69. And now you need to put a unit in there, and I'm not going to tell you what that unit is. You should know by now. And I'll be checking on that one too. So that second blank on the sheet is for the unit of the density of sand. Okay, so I hope that you got the notes down, figured out how to do the calculations. If not, rewind back and see what else you need to do. This is a difficult one, just mostly because it's got crazy steps to follow if you're not understanding it. So try to understand it, and we will do this lab tomorrow when we return.